Trigonometry is very useful in geometry because if we are able to relate the side lengths and angles in triangles, then we are able to derive rules about these relationships. Let's look at a general triangle with the angles and sides labelled with upper and lower case a's, b's and c's. Opposite angle side pairs have the same letter. I will show you how, given certain information about the triangle, we are able to figure out other information about it using trigonometry. First, we find ourselves in a situation where we know two of the side lengths of the triangle and the angle that is sandwiched between those two sides. We will use sides A and B and the angle C, but we can choose any two sides with an angle in between. From this information, we are going to work out A, the area of the triangle, and B, the length of the final side of the triangle. The first thing we're going to do is split the base up into two right-angled triangles, with the perpendicular height of the triangle being the common side, which we call h. We know that the area of this whole triangle is a half times the base times the perpendicular height, and our base is A. Using trigonometry, we know that the perpendicular height is related to the side length B and the angle C by this equation. And so we can write h as B sine C. The area of the triangle is therefore a half times A, the base, times B sine C, the perpendicular height. Now we want to find the side length C, and we again study the two right-angled triangles that make up our triangle. We don't know exactly the length of each of these base sections here, but we know that they add up to A. For this reason, we shall call this section x and this section A minus x. We can express the length h using Pythagoras' equation for both the triangles. Since h is a common side and is the same height in both triangles, we can equate these two expressions. Expanding and cancelling leads to this. Now, x is an unknown, and so is c, but we realise a simple way of writing x in terms of the things that we do know using trigonometry. Cos c is equal to x over b, and so x is equal to b cos c. We replace the x's in our equation with b cos c's and rearrange it for the unknown side length c. We obtain what is called the cosine rule, a general equation for finding the last side of a triangle if we know two sides and the angle wedged in between them. Previously, we expressed the height of the two right-angled triangles using Pythagoras' theorem and equated the two. Now that we know this side, we can express the height in both of these triangles using trigonometry. In this triangle, the height is b sine c, and in this triangle, the height is c sine b. Equating these two and rearranging leads to the sine rule, which holds for all three side angle pairs in the triangle. The ratio of a side length to the sine of the opposite angle is the same throughout the triangle. If we know both the values in a side angle pair and one more piece of information about the triangle, we can rearrange the equation to find the missing piece. For us, we now know the side lengths A, B and C, but the only angle we know is C. If we want to find the angle A, we write out the sine rule, rearrange for sine A and take the sine inverse. We can then do the exact same to find the angle B. These three formulae are important to remember. The derivations of them are not, but I always recommend trying to have at least a general sense for how important formulae have come about. Normally, derivations are based off familiar concepts, such as right-angled triangles. but they tend to just analyse them in more details. So it's easy to follow the general reasoning of a derivation, even if you don't follow every line of math.